Hello, how are you everyone? I hope you're all doing great. Well, today I want to introduce you to this tool called Tinkercad. Okay, I have this document that will walk you through how to install it. I will put a link to download this document under my YouTube channel. So the document goes through a list of material, Arduino, but today we're just gonna go and talk about how the tool works, and there are some supporting videos also that will help you how you can install Tinkercad and how Tinkercad works. Okay, so enough of that. I want you to go to your favorite web browsing application. Mine is Google. So you just type basically under Google search, type Tinkercad. So click on the link where you can log in, and then select. There are multiple choices that you can do. So either you join in as a student in my class, or using an email. I prefer that you just for now just use your email as one option to log into this application. This is a web-based application. All you have to do is sign in. So put your email address, and then so if I put, for example, mine is abejjaji@gmail.com. Go to next, okay, and then put your password, and then you'll be able to sign in. I did all this, so I'm not gonna go to the process. Very easy process, and let me show you what is Tinkercad all about. Okay, so I'm gonna go out from here. I already have an account, and I did the same thing. I'm just gonna go with my Google sign in. I did the same. I provided my email address. They sent me a link to my email, and I responded, and then I'm in. Click on circuits, okay, then create a new circuit. Okay, then you create new circuits. So before we start using this tool, I'll tell you what this tool can do and why we need it. So we're gonna be, most of the classes we're gonna be doing is really using this tool to program. At one point we will buy, you have to buy hardware to actually experiment, but the same effect, you can actually build a circuit using the component that you see here on the right side. Is where we select our component, and in the middle this is actually our canvas. This is where we put our circuit, like there. For example, today what we're gonna do, we're gonna try to lit an LED. It's as basic as it sounds, but we're gonna go from lighting an LED with a power source like battery, to actually taking this LED and putting a switch and turning the LED on and off, on, off with that switch. Okay, and then go further and actually controlling the LED with a microcontroller. And this is very important steps that get us closer to build. Remember, the objective is always to build this car. Okay, so all this series of classes is really to build this car. And if you haven't seen it before, this car basically is a smart robo car, and I called it MR1 or MR1. It has a camera, it has some kind of ultrasound sensor, it has an Arduino, and you can control it with your mobile application that we're gonna build through Wi-Fi. And also we're gonna design this 3D chassis using 3D design. We can use either Tinkercad or Fusion 360, and I will teach you how to actually work with both of them. Okay, so now let's build. The first project is really to blink an LED. So what we need, we're gonna need a breadboard. So I'm just gonna select a small breadboard. You can select a bigger one or a small one. Really, you just rotate it maybe, or just keep it like that. And then we're gonna need a resistor. So I'm just gonna drag a resistor and drop it right here. And we're gonna need an LED, so light emitting diode. I'm just gonna drop this resistor right here for now. So we just pick all the components that we're gonna need for now. Okay, we're also gonna need a battery. Let's say we're gonna use this 9-volt battery. I'm just gonna rotate it so it's facing, okay, this way. We're gonna need, and if you can't find something, let's say I want a push button switch, I just type push button switch and here you go. So I'm just gonna drop it right now here. And so for now, these are the components we're gonna start with first. Okay, so an LED, I already talked about the LED, but it's good to always repeat certain things. An LED stands for a light emitting diode, and basically it's a semiconductor device that actually allow current to only flow from one direction. So it always go from the anode, which is the longer leg. So if I want just to show, actually this is a longer leg, let's draw it. And to draw with this tool, really just click and drag and it will draw for you. So let's say I put this leg here, okay, oh, and you will snap on the hole, okay. And I'm gonna put let's make so it looks like an extension of the LED. Let's make it actually, you select the jumper, and then let's make it where is gray, right here. And then so this is normally the anode is the longer leg and the cathode is the shorter leg, so you just put it right here for now, okay. And let's make it gray also. So now it's exactly looks just exactly just like this one here, okay. Can you see it? It has one, well, let's flip it this way. It has one longer leg and one shorter leg, okay. This is an LED. And so with the LED, the way it's polarized means current will only go through one direction. You cannot swap it. So that's what the role of a diode is, to actually direct current only in one direction. So the current will flow from the positive side, go through the LED, and leaves the cathode, which is the negative side, okay. And if you put the current through here, it's not gonna go. So make sure you are using the LED right. So resistor is nothing but a device or component actually that limits the flow of the electron, make it harder through any device, so it resists the current. So we need that, because if we put 9 volt, complete 9 volt directly to the LED, we're gonna burn it, and we don't want to burn it. And actually, you know what, let's try that and see what's gonna happen. So let's say we are not gonna use a resistor for now, okay, and we're gonna just connect directly this. Well, before getting there, I have to explain you how actually this breadboard works, but let's just show you what I'm talking about. So I'm gonna connect this is the negative and this is the positive side. So to make it look nicer, let's just put this one here, and maybe I can rotate it this way, okay. Now, so this is negative, this is positive. So I'm gonna connect this guy with this guy and just color it in red, and I'm gonna connect this guy. If I go this way, they just go long way, you know. The most important thing is to understand how this thing is working, and they just make it black, okay. So now, okay. So now positive is connected to positive. This is the anode of the LED. That's good. Negative of the LED right here, which is the cathode, is connected to the negative of the our battery. So that's good. So normally it should work. If everything is good, it should work. So let's start simulation. So the this tool actually, it's just like you have an actual battery with an LED and connecting things. So it's gonna simulate actually just like you have physical hardware and you're playing with it with your hand. Okay. So I'm gonna start simulation. Boom! What happened here? So if you don't see it, let's zoom and see what happened. Oh, I think we burned our LED. Wrong. What did we do wrong? You know, did we do something that? Yes, LED has an operating voltage of around 2 volts, and we're supplying 9 volts. So somehow we have to reduce that voltage, okay, to only have around 2 volts dropped across that LED. That's where we need the resistor, okay. And in class number 2, so right now I'm just going to use any value, but in the class next class I will teach you how, I will show you how actually you can calculate the right value of this resistor. Okay, so I'm gonna stop my my simulation. Now I'm gonna replace, and let's just zoom out, and I'm gonna replace, instead of connecting directly, I'm gonna put a resistor. So for now, see, if I want to change the value of this resistor, well, let's just move it out and get another resistor here. Sometimes this window doesn't open, so I just delete that. Okay, so I want to put a value like 220 ohm, and notice that actually when you put a value here, the color change. So this is 220 kilo ohms. When we just want to say we want a 220 ohm. Notice it has red, and brown. Okay, and I will teach you actually the color code. Well, you know, let's do it now maybe, so you can. So basically, let's take this color code resistor table here. So as you see, the colors are coded from top to bottom. Black is 0, brown is 1. If you have a band, red means number 2, and go all the way to white, which is number 9. Okay, so if we take the first type of color code, means this type of resistor that have only 3 bands, that have some kind of tolerance of plus minus 10%. Okay, and this is that we're gonna be working with. Okay, ignore the middle one here. So this resistor has a green. So let's see, without looking at this value, a green. If I give you a resistor with green, blue, and yellow, can you tell me the value of this resistor? Yes, looking at this code here. So what is green? So green give you the first digits of the resistor. So green is 5, so we write 5 here. Okay, blue is 6, so we have 5, 6. Yellow, it give you the multiplier. So the yellow is 4, so we have 56 times 10 to the power 4, which is give you 560 kilo ohm. Remember, kilo is 1000. Okay, so the next step here, let's just, so that's how you calculate basically or know a resistor value.